So in this pattern, we are asked to calculate the sum of this series, and we are told that this series is arithmetic on the statement. So because they told us that it's arithmetic, I know that my first term is negative 2p, right? Then my difference is term 2 minus term 1, which is 2p plus 2p, which is 4p, right? Then to get the number of terms, remember we do Tn and substitute that last position. So we're going to say 102p is equals to the first term, which is negative 2p, plus the difference, and then n minus 1. Then we have 102p plus 2p equals to 4n into 4p, 4p into n minus 1. And then we have 104 this side. It's going to be 104, and then we're going to divide it by 4p. Then we have n minus 1. You can see that the p will cancel the p. So 104 divided by 4 should give you 26. Then we're going to transpose the minus 1. So it's going to be plus 1 equals to n. Therefore, n equals to 27, which means this series has 27 terms. And the nice thing is we know the first and the last term. The last term is there, the first term is here. So we can use the other formula of the sum, this one. Let's see. We're going to say Sn equals to n over 2a plus l. So S27 terms is going to be 27 over 2. The first term is what? It's negative 2p. The last term is 102p. Then we have 27 over 2 is equals to 100p. Because 102 minus 2 is 100p. And then let's see. We have 27 over 2 times 100. That gives us 1350p. And that is the sum of these 27 terms, ladies and gents, in terms of p. And that's it. Dango.